Degeneracy in transportation problem. Already I studied without degeneracy how to solve. Process will be same, but only we have to check here degeneracy and we have to make it degenerate if it is not degenerate. The problem is that it has been solved by VAM method. We'll get this matrix after that. VAM method has been explained in one more video. If you want, you can go through that. Here in this, after VAM method, we'll get this matrix. In this matrix, allocations are given, everything will be given. Allocations are nothing but this is one allocation, this is second allocation, this is third, this is four. Four allocations are there. Just leave this delta. That delta I will explain in this problem. After VAM method, what we got? 1, 2, 3, 4 we got. Right. Now, what is M plus N? U1, U2, U3 plus V1, V2 with that is nothing but 3 plus 3 minus 1. M plus N minus 1 equal to 5. 3 plus 3 minus 1 equal to 5. But allocations are 1, 2, 3, 4. 4 are there. To make it equal, we have to assign this delta. Where we have to assign this delta? From unallocated cells 8, 7, 8, 11, 5. 8, 7, 8, 11, 5. From these, we have to select least value 5, 11, 8, 7, 8. Least value is 5. Even it is least, sometimes if it makes loop, you cannot assign delta for that. Here, 5 is the least. For this least value, we have to check whether it will make any delta and any loop or not. Means how loop will be made. First I will explain here. This delta is not there, just leave. There is no delta here. 5 is there. From this, when you go for next, it should be allocated for loop making. And next you have to go for this. There is a allocation. Next from this, when you are coming back to 11, it should be allocation to make the loop. Right. From 5, you can go for this 3. But next from 3, there is no allocation. You cannot go for looping. From 5 you can go for 3, but there is no. Means 5 is not making any loop with its alternative allocated cells. Is it clear? 5 is least value and it is not making any alternative loops with any allocated cells. Because of that, 5 is selected for allocating delta. Delta already not allocated. We have to allocate delta to make it allocation equal to 5. Right. 5 is not making any loop with alternative allocated cells. With 3 also it is not making because this is empty. With 20 also it is not making. Third is empty. With 60 also, with 3 also it is not making. Alternative will be empty. So that 5 is selected for assigning delta, and delta value is very least. You cannot consider this for calculation. Just for making allocation equal, we are assigning this delta. Please keep that in mind. How to allocate delta I have explained. You have to select the least value from unallocated cells. That unallocated should not make any loop with alternative allocated cells. If it makes in some problem, what it makes, the least value will make alternative loop, then you should not consider that as a least. Next you have to go for next least element to make delta allocation. If it makes loop with any other allocated cells, then you should not consider that for assigning delta. Then go for any other. 5 is there, then go for 7. You can check like that. Here 5 is not making any loop. Because of that, for 5 I am assigning delta. If it makes a loop, then you cannot assign delta for this. Then go for second least, that is 7. Then you have to check. Here it is making there is no loop with any other alternative allocated cells. Because of that, I am assigning delta for 5. Please remember this procedure whatever I have explained, otherwise it will be difficult. I have written, I thought I have written, you can go for that, and delta value is always negligible. Once again the same procedure for allocated cells, because now allocated cells will become equal. 60, 1, 2, 3, 4, 5. 5 equal to 5 I have made. Now we can go for the same procedure by Modi method, that is U1, U2, V3, V1, V2, V3. For allocated cells we have to calculate U1, U2, U3 and V1, V2, V3. For allocated cells U1, V1 equal to 8. Next, allocated cells U1 plus V3 equal to 3. u2 plus v1 equal to 3, u2 plus v3 equal to 9, u3 plus v2 equal to 3, u3 plus v3 equal to 5. And you can take v3 equal to 0 or directly u1 equal to 0, no problem. Some books they have taken without any maximum allocation, directly u1 equal to 0. Now I have taken v3 equal to 0 here, v3 equal to 0 because maximum allocations are there. Because of that I have taken v3 equal to 0 to calculate u1, v1, u2, v2 and u3. After these, once again go for unallocated cells, x11, x12, x21, x31, x, so all these four, right? x11, c11, u1 plus v1, 1 is nothing but u1 plus v1, c11 minus u1 plus v1, u1 and v1 are calculated in the above step, and c11 is nothing but 8, c11 is called as 8. Next c12 is called 7, c22 is called as 8, c31 is called as 11. Those are the values from the matrix. These values are from the matrix, and u1, v1, u1, v2, u2, v2, u3, v1 are calculated in the step before. So after value will get 11, 2, 1 and 12. So these are the values. I explained in Modi method of optimality test that if the values of x are positive, then it satisfies the problem. Right. So there is no more step we have to go. Here it completes the complete problem, and we have to calculate the value. 3 into 50, right, 3 into 60, 3 into 80, 9 into 25, you cannot take delta. Right, delta value is 0 we are considering, because of that you cannot take. 750 is the answer. Here it is called as checking of degeneracy problem. Only important part, phi is not equal to 4 here. To make phi equal to 5, what you have to do? You have to assign delta. Right, you have to assign delta. Where you have to assign delta? For the least of unallocated cell, and that least should not make any loop with alternative allocated cells. That is very important in this degeneracy problem. I thought one more problem I have solved here. We'll go for it in. So after some method we got allocation here, right? After least cost method we got allocation here. In this allocation, number of allocation I have to check 1, 2, 3, 4, 5, 6, 7, 8. 8 allocations are there, right? There are 8 allocations are there. Only I will explain degeneracy. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. 9 minus 1. 4 plus 5 minus 1. 9 minus 1 equal to 8. But what are the allocations? 1, 2, 3, 4, 5, 6, 7 allocations are there. So delta has been assigned for the list. Now go for unallocated cells. 10 is there, 15 is there, 9 is there, 5 is there, 10 is there, 15 is there. Unallocated cells, 7 is there, 14 is there, 5 is there, 20 is there, 15 is there, 28 is there. From these values, there are 2 5s are the least value. Delta already assigned after checking. Here there is no delta now. I am explaining. There is no delta now. So this pi and this pi are the least. You can take any one pi. For this pi, what you have to do? Check whether it is making loop or not. Now from this only one allocated cell is there. That is here. Next you have to go for allocated. There is no allocated. There is no allocated. There is no any allocated cells alternatively. Because of that, this pi is not making any loop with allocated cells. Because of that, we have to assign delta for this pi. You can take this also, or you can take this also. You have to check. This pi is not making any loop, means there is no go for other element. So because of that, we have assigned delta for here, and to make this 8 equal to 8. I have explained here. You just go through that. You have to select the least value and check whether that least value is making any loop with alternative allocated cells. If it is not making, find allowed delta for that. If it is making, then leave that, go for next alternative least value and check whether it is making loop or not. This is the degeneracy. After degeneracy, process will be same. Just go through the problem I have solved and solve this problem by yourself. Then you will get answer. Thank you. One more problem I given for you to solve. Just go through that.